What I've got here is the Tompkins County, and I've cut out a town of Dryden data set, the roads, and we're going to key into this area a little bit. And so let's zoom in and reduce get a little bit more detail here. The premise is that we've got 4 study areas within the town of Dryden, and we want to extract out information, data sets from data sets for these 4 study areas, which we'll then use to compare the attributes between the 4 study areas and make some sort of a selection, that type of thing. And the tools that we're going to look at are our clip is one of them. And the first one, so we'll go up to the geoprocessing menu at the top here, and we'll click on that. And there's the clip tool. Now we've already used the buffer tool earlier, and after clip we'll do the intersect. So we'll look at clip and intersect this time. So let's just open up the clip tool and see what we have. Now, clip tool, this is the dialog for the clip tool. And like all the tools in ArcGIS, we have a little bit of a graphical help on the side, which gives you some idea as to what's going to happen if you run the tool, and also gives you some clues on the input features for the different variables. So our input is our larger data set, the piece from which we want to extract information, and that goes in the input features. We'll go over to the dialog and we will input the features. And then we'll have to identify a clip feature, which will be our polygons that we're going to use to perform a cookie cutter type of arrangement and extract the information that falls within those polygons. And then of course we'll have to identify an output for those. So let's start filling out the dialog a little bit. So for input features, we'll select the land use land cover data set, and we're going to extract the land use land cover data set that falls within each of those 4 areas. So we'll identify that as our input feature. Our clip feature is our 4 areas polygon, and the clip feature has to be a polygon layer. And then of course we have to give it some sort of an output. And in this it's defaulting to going into a geodatabase we've created, so we can let it go with that. Perform the clip operation, and then down in the lower right you see it was running in the background. So let's turn off some of this the background of the Dryden and see what our clip really has looked like. So turn off the original data set, and there's the clipped data set. We only have those features in those 4 polygon areas, and all of the attributes, all the information associated with those features went with the to the output file as well. And you can see what it does, simply cuts. Uses essentially a cookie cutter and cuts right across the edge there, and we have a nice data set. If we open up the attribute table for that clip layer, we can see that the information associated with the original land use land cover data set came along with it. We've got the name, the different classifications, agriculture, vegetative cover, that type of thing, wetlands. That all comes along with it. However, the polygons are cut, and since we are using a geodatabase, our shape length and shape areas are updated automatically for us. However, you want to be careful of any other fields like acres and hectares after you do something like this, because those will not automatically be updated, and you're going to have to go in and recalculate acres and hectares based on your shape area and shape length, the 2 fields that are automatically updated. So you need to keep that in mind when you start using things like clip, because they are cutting the polygon, but they're not going to change those user-defined fields and update them. So that's basically what CLIP does. It's great for reducing your data set to a specific study areas or area. And and we use it a lot for such things as taking countywide data and clipping it to townships, taking statewide data and clipping it to counties and so forth. So the other tool we want to look at today is Intersect. So if we go down, it's the third one in the geoprocessing menu, and we pop up Intersect. And here's Intersect, and again we have the graphical hints and help on the side. And if you want much more detail, you can click that tool help down at the bottom, and it'll go out and give you the actual help page and gives you lots of detail as to what's going on with this tool. So basically we want multiple inputs, and it will find the area of overlap between those inputs, however many you have. And so let's input, in this case, we're going to input the Dryden land use data set. And we're going to have it going output into the land use Intersect for an output file. And we have to have another input layer. So let's add in the 4 areas again. So what we're going to get here is the areas, the 4 areas that we identified, the 4 polygons, and the intersection with the land use data. And we'll let that process, and again it's doing it in the background, and it's done. And it looks very similar to the same what we got on the clip. So let's turn off the clipped layer and take a look at this data set. And there's the intersection layer. And the big difference, it looks very similar to what we got with clip. Essentially looks the same from this view. And indeed it's pretty much the same. You got the polygons and all of that. But the real difference is if we go into the attribute table for the results from our Intersect. And when we actually go and open that attribute table, we realize that with the Intersect, not only did it, with the clip, we just got what was in our input file. We just kept those attribute table information. With the Intersect, we not only keep the original land use data information, but we also have associated with it the polygons that we used as a clipping or as an Intersect tool. So we can identify every polygon according to which of the 4 regions it fell into. So we have the normal land use information, but we also have our area ID, Site A, Site B, Sites C and D. So by intersecting, we join, or we combine the attributes from both of the layers, or from all of the layers, because it could be a multiple set, not just 2. We combine all the attribute information. And that allows us then to be able to specify, well, show me everything that's in one specific site versus another site, or do a very detailed queries on those attributes, looking at all different input parameters. So just for an example, we can go and we can select, this is the original clip, and I just wanted to show you that we have no information. We could select a polygon, but we do not know which of the 4 sites that polygon falls into, without us actually physically looking at it on the screen. But with Intersect, we automatically have the attributes combined. We can then do a summation based on area ID and get total area in each of those sites. We can summarize all kinds of things. We can do selections. We can grab all the information from one site and save it out and do whatever else we want to do. So by doing the Intersect, we combine the attributes. We can then go ahead and do some sort of a simple summary. I'm just doing a quick one just to show you, and it's not going to give us much. Basically just giving us the first occurrence of any any land use in site A, B, C, and D. But of course, we could have summed up all the land use values in A, B, and C, and D, and we can do a number of processing from there. We could also do a query as to find which site had which attributes. So with Intersect, we could do that. The clip is a simple cookie cutter kind of approach to reducing your data set. So when you want to reduce your data set and you're not interested necessarily in combining attributes and you're only dealing with one, you just want to clip subset information out, use clip. Just extract a subset. If you are interested in pulling data together and you want to find that area where they all overlap, then use Intersect. And in that process, you will combine all the attribute information. Of course, you can opt not to combine the attribute information if you want, but in most cases you do want it all in there, and then it allows you to do a lot more analysis at a later stage. And of course, you can save all this information out. That's the other option that we have for reducing our data set, not associated with the geoprocessing wizard, but anytime we create a selected set, and I'm going to go ahead and select by certain attributes here. So let's say we want all of site B, so we grab all the polygons that are in site B, and we have all the land use information there. And since we have a selected set, this is another way to subset your data. We can export that, and we can export the information in the attribute table by using the menu in the table for and going to the menu and selecting export, and that will export out a table, and it could be a dbase table or an info table, whatever it is we would like to have. And you just go to the menu, go down to export, and you'll have the dialog, and from there you can fill in the blanks. But you notice that it says export selected records, and we can spit those all out. Of course, you can export the whole thing as well. You can, at any time, you can export a whole data set. Now, the other thing we could do is, besides exporting the records, if we go back to the layer itself with this selected set, and we'll have to change our view a little bit. We might want to export not just the attributes, but maybe we want all those polygons too. We're going to do a study just in this area, and we're going to create whole new data sets of just this site B. So we go back, we change our table of contents view a little bit, and then we can right-click on a layer, and inside any layer, there's an option under the data choice in the context menu. There's an export data option. And when you select that, you're presented a similar dialog as we received within the attribute table export, where you can say export the selected set or export the entire data set. And so this will take only the selected polygons, in this case only all the polygons in site B, and all the attribute information of course goes along with them, and we would just need to give it an output name and type, whether it's into a shapefile or whether we also have the option where we could put it into a geodatabase. So lots of couple 2 or 3 different ways of reducing your data set.